Welcome to our channel. There is something astonishing about the sky when it suddenly breaks its own rules. One moment, the sun shines with familiar brilliance, and the next, it fades as if an invisible force is swallowing its light. Or the moon, usually calm and silver, transforms into a glowing red orb that looks almost otherworldly. These moments feel mysterious, dramatic, and even a little unreal. Yet behind this cosmic spectacle lies a story of perfect alignment, delicate geometry, and powerful shadow play that has fascinated humanity for thousands of years. In this video, we explore the extraordinary phenomenon of eclipses, both solar and lunar. You will learn how these rare events occur with breathtaking precision, why each eclipse looks different, and how tiny shifts in distance and motion create scenes that seem impossible. We will uncover ancient beliefs, scientific milestones, and the quiet elegance of the sun, earth, and moon moving in harmony. You will discover why a total solar eclipse can feel like the sky is rewriting itself, why a lunar eclipse glows with a strange crimson beauty, and how eclipses helped scientists measure our world, test bold theories, and understand the universe with new clarity. By the end of this journey, you will see eclipses not just as beautiful events, but as powerful reminders of how deeply connected we are to the motions of the cosmos. If you enjoy learning about the wonders of the universe, please like this video, subscribe to the channel, and let's begin. Take a moment and look up at the sky in your mind. Most of the time, it feels steady and predictable. The sun rises, the sun sets, the moon grows, the moon fades. These patterns are so regular that we barely think about them. But every once in a while, the sky breaks its own rules. Light disappears when it should not. Shadows stretch across the world in strange shapes. The moon turns red. The sun becomes a dark circle with a ring of fire around it. These moments are rare, sudden, and unforgettable. They are called eclipses, and they have been surprising people for thousands of years. Imagine standing outside on a warm day. The sun is bright, birds are singing, people are talking, and life feels normal. Then the light begins to fade. Not like a sunset, not like a passing cloud. It fades in a slow but powerful way that feels unnatural. The temperature drops. The world becomes quiet. Animals behave strangely. You look up, and the sun is being covered, piece by piece, by the moon. The sky darkens in the middle of the day, and suddenly everything feels different. This is the feeling humans have experienced during solar eclipses long before science explained them. Now picture another scene. It is night. The moon is full and bright, lighting up the sky. You look at it often because everyone has seen a full moon many times. But tonight, something unusual happens. A shadow begins to creep across its face. The bright circle becomes dim, then rusty red, then almost brown. It looks like the moon has changed into a glowing ember. This strange transformation is a lunar eclipse, and it is just as enchanting as the daytime event. Eclipses feel magical because they do not happen often, and also because they challenge our normal sense of time and space. They remind us that we live inside a giant system of motions. The sun, the earth, and the moon are constantly moving, constantly shifting their positions, even when we do not notice. And when these three bodies fall into a perfect line, something dramatic happens. It is a reminder that the universe is precise, delicate, and deeply connected. If you think about it, the sun is so huge that more than 1 million Earths could fit inside it. The moon is so small that it is about 1/4 the width of Earth. And yet, from our point of view, the moon can completely cover the sun for a few minutes. This is possible because of an incredible coincidence. The sun is about 400 times larger than the moon, and the sun is also about 400 times farther away from us than the moon. This makes them appear almost the same size in the sky. Without this coincidence, solar eclipses would never look so perfect and dramatic. Most days, the moon passes above or below the sun in the sky. That is because its orbit is slightly tilted. But when the moon, Earth, and sun line up exactly, the moon's shadow falls on Earth. This creates a solar eclipse. Depending on how far the moon is from Earth at that moment, it can either fully cover the sun or leave a bright ring around it. When the moon is close to Earth in its orbit, it appears large enough to block the entire sun. This is called a total solar eclipse. When the moon is farther away, it appears a little smaller, so a ring of sunlight remains around the edges. This is called an annular eclipse, sometimes known as the ring of fire. The moon's shadow, that creates a solar eclipse, is not the same everywhere. The darkest part, called the umbra, is where the sun is fully covered. Only people standing inside this narrow path can see totality. This path may be only a few hundred kilometers wide, but it stretches across continents. The shadow moves at high speed across Earth, sometimes faster than 1,000 kilometers per hour. Standing inside this path is what gives people the breathtaking experience of total darkness in the middle of the day. Even outside the path of totality, people can still see a partial eclipse, where the moon blocks only part of the sun. A partial eclipse is still interesting, but it does not create the sudden darkness or dramatic atmosphere of totality. That is why so many people travel long distances just to stand inside that narrow path. They want to feel the moment when the world changes for a few minutes. Lunar eclipses, on the other hand, are easier to watch. Anyone on the night side of Earth can see them. The moon does not disappear completely. Instead, it passes through Earth's shadow. When that happens, sunlight that travels through Earth's atmosphere bends and reaches the moon. But this light is filtered by dust, air, and particles. The shorter blue light gets scattered away, while the longer red light makes it through. That is why the moon turns red or copper during a total lunar eclipse. This color can change based on what is happening on Earth. Volcanic eruptions, wildfires, or atmospheric dust can make the moon appear deeper red, brighter, or even slightly brown. Both types of eclipses show us something important about our place in the universe. They show us that even though we feel stable and grounded, we are actually riding on a moving planet spinning through space. We are part of a system that is always shifting. Most days, this system moves quietly, without drawing our attention. But during eclipses, the system reveals itself in a bold way. The sky becomes a stage for cosmic geometry. Ancient cultures saw these events with fear and wonder. Many believed that something was wrong with the world when the sun or moon was covered. Some thought that monsters or gods were swallowing the sun. Others believed that eclipses were warnings or messages from the sky. Over time, people began to observe patterns. They noticed that eclipses follow cycles. Slowly, they learned to predict them. And as human knowledge grew, these once mysterious events became windows into the science of light, shadow, and motion. Eclipses also changed how we see ourselves. They helped early astronomers understand distances, sizes, and orbits. They helped scientists test ideas about gravity and space. They continue to help researchers today measure the atmosphere, the sun's outer layers, and even the movement of Earth. In many ways, eclipses have shaped our understanding of the universe. But beyond all the science, eclipses remain emotional. When you stand under a solar eclipse, everything inside you reacts. You feel the world shifting into something unfamiliar. You feel small and amazed. You feel connected to something bigger. It is one of those rare experiences that stay with you forever. This video will take you through the story of eclipses in a clear and simple way. You will learn how they happen, why they happen, what they meant in the past, what they mean today, and how they will change in the future. You will see the deep beauty in the way shadows move through space, and you will understand why these events continue to capture human imagination across cultures and centuries. When you finish this journey, you will not look at the sun, the moon, or the sky in the same way again. Think about the three main characters in this story: the sun, the earth, and the moon. They move through space in a dance that has been going on for billions of years. Most of the time, their paths do not cross in a dramatic way, but sometimes their positions line up so perfectly that something surprising happens. Before talking about these special alignments, it helps to imagine how these three bodies move and how they relate to one another. Start with the sun. It sits at the center, enormous and blazing. It is the source of almost all light and heat in our solar system. Without it, Earth would be cold and silent. The Earth moves around the sun in a giant orbit that takes 1 year to complete. At the same time, Earth spins on its axis, giving us day and night. The moon moves around Earth, taking about 27 days to complete one orbit. So the moon is always shifting its position as Earth and the sun continue their own motions. If you could draw the paths of these three bodies in the sky, it would look like a set of circles and tilted lines. The moon's orbit is slightly tilted compared to Earth's orbit around the sun. This tilt is the reason we do not get eclipses every month. If everything lined up perfectly on the same plane, then every time there was a new moon, we would have a solar eclipse, and every time there was a full moon, we would have a lunar eclipse. But the tilt means the moon usually passes a little above or below the sun from our point of view. Only when the tilt, the angle, and the timing all match do we get the shadow effect that becomes an eclipse. To understand this better, imagine standing in bright sunlight. If someone stands in front of you, blocking the sun, their shadow falls onto you. A solar eclipse works in a similar way, except the object blocking the light is the moon, and the shadow it casts falls on Earth. This shadow is not the same in every place. It has different layers. The darkest inner part is the umbra. If you stand inside that dark cone of shadow, the sun will be completely hidden. The outer part of the shadow is the penumbra. If you stand inside that lighter zone, the moon will cover only a part of the sun. These simple ideas of shadow and light help explain why eclipses look so different depending on where you are. The moon's shadow is small compared to Earth. That is why the path of a total solar eclipse is narrow. It sweeps across Earth like a moving ribbon. But the path of a lunar eclipse is enormous because, in that case, Earth's shadow falls on the moon. Anyone on Earth who can see the moon during that time can witness the event. This is why lunar eclipses are more common for people to watch, even though solar eclipses happen just as often somewhere on Earth. One beautiful detail is how Earth's atmosphere affects light during these events. When sunlight passes through the edges of Earth's atmosphere, the blue and green colours scatter away, leaving the red and orange hues. These warm colours travel through space and fall onto the moon during a total lunar eclipse. The result is the familiar red glow of the blood moon. The shade of red can change depending on the conditions of Earth's air. If the atmosphere contains more dust, ash or pollution, the moon might look darker, deeper red, or even slightly brown. So in a way, the moon during an eclipse shows us a picture of Earth's atmosphere painted onto its surface. The sun, Earth and moon each move at different speeds. The moon orbits Earth once every 27 days. Earth orbits the sun once every year. The sun itself spins on its own axis in about 25 days near its equator. These movements are separate, yet they create moments where everything aligns. These alignments are delicate, almost fragile. When they happen, it feels like a secret door has opened, letting us see the universe from a fresh angle. In daylight, the sun feels far away and unreachable. But during a total solar eclipse, it becomes something else entirely. The sky darkens, and the sun turns into a black circle surrounded by a glowing white ring. That ring is the solar corona, a layer of the sun that we cannot see on normal days because its light is drowned out by the sun's brightness. During an eclipse, the moon blocks the bright middle part, revealing the corona like a ghostly flame. People who have seen totality often describe it as the most beautiful sight in the sky. Some say it feels like being transported to another world. The sun's corona is very important to science. It is much hotter than the surface of the sun, even though it sits farther away from the core. This strange fact has puzzled scientists for years. Eclipses give humans a chance to study the corona in more detail. Before we had advanced telescopes and spacecraft, solar eclipses were the only way to observe this mysterious outer layer. Even today, scientists still use eclipses to learn about solar winds, magnetic fields, and other powerful forces coming from the sun. Another interesting idea is how eclipses helped humans understand the shape of Earth. Long before satellites or maps, people noticed patterns in eclipses. For example, during a lunar eclipse, the shadow that Earth casts on the moon is always curved. This revealed that Earth must be round, because only a round object always casts a circular shadow, no matter the angle. This was one of the earliest clues that Earth is not flat. So eclipses were not just dramatic events, they were tools that helped people make important discoveries. As humans learned more, they realized that eclipses follow cycles. One of the most famous cycles is called the Saros cycle, which lasts about 18 years. After this time, the Sun, Earth and Moon return to nearly the same positions, and a similar eclipse occurs. Ancient astronomers in Babylon and Greece studied these cycles and used them to predict future eclipses. This ability to predict something so dramatic gave them great credibility and power. It is fascinating to think that thousands of years ago, people without modern tools could understand the sky so deeply. Eclipses also helped shape myths, stories, and beliefs. Many cultures saw solar eclipses as attacks on the sun. In some places, people would shout, bang drums, or make loud noises to scare away the creature they believed was swallowing the sun. In India, stories of Rahu and Ketu explain the sudden darkening. In China, people believed a dragon was eating the sun. These myths were ways for early societies to explain something that felt frightening and mysterious. Over time, the fear changed into curiosity, and curiosity turned into knowledge. Even today, eclipses carry emotional weight. People travel across countries to stand in the path of totality. Tourists gather on mountains, beaches, and wide open fields. Scientists set up cameras and instruments. Families bring blankets and watch the sky together. It becomes a shared moment, one that brings people closer. When the shadow falls and the world quiets, there is a collective pause, a breath held by everyone under the moon's shadow. It is a reminder that even in our fast and busy world, nature can still surprise us. One beautiful thing about eclipses is how they show the balance between vast time and personal time. These events depend on movements that take millions of years to develop. The size of the moon, the distance from Earth, the tilt of the orbit, the speed of the shadow, all these things were shaped over cosmic time. Yet the event itself lasts only a few minutes. You wait for years, travel across great distances, and then the light fades for just a moment. It is a small slice of time inside a giant cosmic pattern. That contrast makes eclipses feel even more precious. When the moon is just the right distance, the sun and moon appear to fit perfectly. But this perfect fit will not last forever. The moon is slowly drifting away from Earth by a few centimeters each year. Someday, millions of years from now, it will be too far to fully cover the sun. Total solar eclipses will end. Future humans, if they exist, will only see annular eclipses. That means we are living in a special time in Earth's history, a time where total solar eclipses are possible and visible. In the vast timeline of the universe, this is a brief and lucky moment. As you listen to this story, keep imagining the sky not as a static ceiling above us, but as a moving stage filled with motion and rhythm. Eclipses are one of the rare moments when the motion becomes visible. They let us watch the universe at work. They remind us that Earth is not a quiet place fixed in the middle of nothing. It is part of a system full of connection, light and shadow. When these shadows fall in just the right way, the world changes, if only for a little while. When you think about a solar eclipse, it helps to imagine the moment when the moon begins its slow journey across the sun. The first bite appears on the sun's edge, almost like something small is nibbling at it. At first, it does not feel strange. The sunlight is still bright, the sky still looks normal. But as the moon covers more of the sun, the light around you begins to change. It becomes softer, but also sharper, in an unusual way. Shadows look different. They look sharper and more defined, as if the world is being drawn with a harder pencil. You start noticing tiny crescent-shaped shadows under trees as the sunlight passes through leaves. Everything feels familiar and unfamiliar at the same time. The sun does not dim like a lamp being turned down little by little. It has a dramatic personality. Even when half of it is blocked, it is still extremely bright. That is why you need special filters or eclipse glasses to look at it safely. The sun can harm your eyes in seconds, but with the proper protection, you witness a slow and steady transformation that is both peaceful and powerful. You watch the moon, a silent traveler, move across the sun's face, like a dark coin sliding across a golden disk. As the moon approaches complete coverage, the world begins to shift in a deeper way. The warmth of the sun drops quickly. You might feel a chill in the air. Birds may stop singing. Sometimes animals go quiet or begin acting as if evening is arriving early. The wind changes direction or grows still. People around you stop talking and look up with a sense of awe. Even if you know exactly what is happening, the moment still feels like a piece of ancient magic. It is as if the natural order is pausing, waiting for something extraordinary. Just seconds before totality, the sun shines through the valleys of the moon's surface. This creates bright spots called Bailey's beads, where small beams of sunlight break through gaps on the moon's edge. These beads sparkle like tiny diamonds. Then for an instant, only one bright spot remains. It shines like a jewel next to the dark circle, creating the famous diamond ring effect. This moment marks the final breath of sunlight before the world slips into eclipse darkness. When totality begins, the change is immediate and dramatic. The sun disappears completely, and the sky becomes dim like twilight. A dark disk hangs in the sky, perfectly round, perfectly quiet. Around it shines a glowing white halo. This is the solar corona. It spreads out in delicate patterns, sometimes smooth, sometimes feathery, sometimes shaped like shining wings. The corona is much larger than the sun itself, stretching millions of kilometers into space, but we cannot see it in daylight because the sun's brightness overwhelms it. Totality reveals this hidden world of light. People who experience totality often describe it as emotional, overwhelming, or even life-changing. It is not just the sight, but the feeling. The world becomes still. The horizon glows faintly because sunlight still touches areas outside the shadow. Stars or planets may appear above you. You see the sky, the landscape, and the corona all together in a way that no photograph can truly capture. Human senses are not used to seeing day and night merge in this strange combination. It feels like time has stretched open, creating a moment that belongs to neither day nor night. Totality lasts only a few minutes at most. The longest possible duration is about 7.5 minutes, but most eclipses last far less. After totality, the sun reappears slowly, reversing the entire process. The diamond ring flashes again, Bailey's beads appear once more, and daylight returns. People often cheer, clap, or fall silent with emotion. It is a shared experience that connects strangers. For many, the first total solar eclipse becomes the beginning of a lifelong journey to chase more of them. Now think about the different types of solar eclipses. A total eclipse is the most dramatic, but not all eclipses can become total. Sometimes the moon is too far from Earth to fully cover the sun. When the moon is farther away, it appears smaller, and it does not block the sun completely. Instead, the sun appears as a bright ring around the moon. This is an annular eclipse, often called the Ring of Fire. The sky does not darken as much as during a total eclipse, but the view is still stunning. The sun becomes a perfect circle of fire surrounding a dark center. There are also hybrid eclipses, which are rare. In some parts of the world, A hybrid eclipse appears as an annular eclipse, while in other places it becomes total. This happens because Earth is curved, and the distance between the Moon and different points on Earth changes slightly. A hybrid eclipse is like two eclipses combined into one event. Partial eclipses are the most common. In a partial eclipse, the Moon covers only part of the Sun. People see a sun shaped like a crescent or a large bite taken out of it. While not as dramatic as total or annular eclipses, partial eclipses still teach us about the movements of celestial bodies. They also offer a chance for people in many parts of the world to experience at least a part of the event. The path of totality, where a total eclipse is visible, is extremely narrow. It might be only a few hundred kilometers wide, but it stretches across thousands of kilometers. Imagine the Moon's shadow as a long moving spotlight. It touches Earth in one location, then races across the surface at high speed. The shadow can move at more than 1,000 kilometers per hour. If you stand inside that path, you experience the full eclipse. If you stand even a little outside it, you see less. This is why people travel great distances to place themselves exactly within the shadow's path. The way the shadow moves across Earth is influenced by the motions of both Earth and the Moon. Earth rotates from west to east. The Moon orbits Earth in the same direction, but moves faster relative to Earth's surface. These combined motions make the shadow travel across the planet in a sweeping path. Each eclipse draws a different path depending on the angles and distances involved. Some paths cross over oceans, deserts, mountains, or populated cities. Some paths are long and dramatic, others are short and pass mostly over water. Solar eclipses have been used throughout history to measure and confirm important scientific ideas. One of the most famous uses was during the 1919 solar eclipse, when scientists tested Albert Einstein's theory of general relativity. According to Einstein, massive objects, like the Sun, bend space, causing light to curve around them. During the 1919 eclipse, astronomers measured the positions of stars near the Sun's edge, which would normally be invisible due to sunlight. Their results confirmed Einstein's prediction. This moment changed our understanding of the universe and placed general relativity at the center of modern physics. Solar eclipses also help scientists learn about the Sun's corona. The corona behaves differently during quiet solar periods and during stormy periods when the Sun's magnetic fields are stronger. Eclipses allow researchers to photograph and study these shapes. By looking at how the corona changes over time, scientists gain clues about solar winds, magnetic loops, and energetic particles that can affect Earth's technology and satellites. Though eclipses are powerful tools for science, they are also deeply personal experiences for many people. Standing under a total eclipse can make you feel connected to ancient humans who saw the same event thousands of years ago. They did not have scientific explanations, but they felt the same chill, the same awe, and the same sense of mystery. Eclipses create a bridge between the past and present, reminding us that human curiosity is timeless. But not every solar eclipse is viewed with joy. Before people understood them, eclipses often caused fear. Imagine being a farmer thousands of years ago. You're working under the bright sun when, slowly, the sky darkens. The sun disappears. You have no explanation. You fear that something terrible is happening, something larger than life. Many civilizations responded to this fear with stories that gave meaning to the event. These stories might not have been scientifically accurate, but they helped people make sense of the sky. Even with all the knowledge we now have, the emotional power of an eclipse has not faded. Modern people know the exact time and place of an eclipse. They know why it happens. Yet when the light fades and the world changes, they still gasp. They still feel a deep sense of wonder. They still look at the sky with the same wide eyes that ancient humans did. Solar eclipses remind us that even in a world full of technology and information, there are still moments when nature takes the lead and shows us something extraordinary. These moments cannot be bought controlled, or recreated. They arrive, change the world for a few minutes, and then disappear, leaving memories that last a lifetime. There are people called eclipse chasers who travel the world to see every total solar eclipse they can. They follow the paths of upcoming eclipses, book flights months or years in advance, and stand in fields, deserts, mountains or beaches just to witness the brief moment of totality. Some describe the feeling as addictive. Others say it is the closest thing to seeing the universe reveal its secrets. Whatever the reason, their passion shows how powerful and meaningful these events are. Solar eclipses are one half of the story. The other half unfolds at night, when Earth's shadow plays its role. Lunar eclipses offer a quieter, slower, but equally fascinating view of the cosmic dance. While solar eclipses strike quickly and dramatically, lunar eclipses move with calm, steady grace. They turn the moon into a canvas painted by Earth's atmosphere. Together, solar and lunar eclipses show two different sides of the same beautiful system of motion. A lunar eclipse begins quietly. The night looks normal at first. The moon rises or sits already in the sky, glowing with its usual bright, calm light. Most people do not notice anything unusual in the beginning, but slowly, something subtle starts to happen. The moon enters the penumbra, the outer part of Earth's shadow. This first step is gentle, almost unnoticeable. The moon might look a little dimmer, but only someone paying close attention would see the change. It feels like the sky is taking a long breath before the main event begins. As the moon continues moving into Earth's shadow, it reaches the darker part called the umbra. This is where the eclipse becomes obvious. A curved dark bite appears on the moon's bright edge. Slowly, the shadow creeps across the surface, step by step. The moon does not disappear all at once. It fades like a dimming lantern. The smooth motion of the shadow makes the event feel calm, steady, and almost dreamlike. There is no rush. Nature takes its time, letting people watch the transformation unfold. One of the most beautiful things about a lunar eclipse is how slowly it happens. Unlike the quick drama of a solar eclipse, a lunar eclipse can be watched at a relaxed pace. You can sit outside, look up at the sky, talk, take photos, or simply enjoy the stillness. The moon's surface changes shape gradually, giving everyone a chance to follow along. You do not need special glasses or equipment to see it. You can look at it directly with your eyes. This makes lunar eclipses feel friendly and accessible, something anyone can appreciate without preparation. As the moon becomes more covered by Earth's shadow, something magical begins. The moon starts to glow with a deep, warm color. The exact shade can vary. Sometimes it is bright red, sometimes copper, sometimes rusty orange, and sometimes a mix of all these colors. This is the famous blood moon. The reason for this color is Earth's atmosphere. When sunlight passes through the edges of Earth's atmosphere, the air bends the light and sends it toward the moon. But the atmosphere blocks the shorter blue and green wavelengths. Only the longer red and orange wavelengths make it through. So the moon becomes painted with the color of Earth's filtered sunlight. This natural filter can change depending on the condition of Earth's air. If the atmosphere has more dust, ash, or particles, often after a volcanic eruption or wildfire, the moon may appear darker or more red than usual. If the air is cleaner, the moon might look lighter or more orange. In a way, the moon during an eclipse is showing us a reflection of what is happening on Earth. It is like a giant mirror in the sky, coloring itself based on the state of our atmosphere. As totality approaches, the moon becomes fully swallowed by the umbra. When the eclipse reaches totality, the entire moon glows with a soft, eerie color that feels gentle and mysterious. Stars become more visible around it because the bright, full moon is no longer dominating the sky. The night feels different, almost deeper. The moon does not vanish, instead, it transforms. It becomes something new and beautiful, glowing quietly like an ember floating in space. Many people find lunar eclipses peaceful, even comforting. The slow pace, the warm color, and the calm night sky create a feeling of serenity. There is no sudden darkness like in a solar eclipse. There is no sharp drop in temperature. There is no rush of fear or awe. Instead, the event feels more like a gentle shift in the sky, a slow unfolding of color and shadow. Lunar eclipses also remind us of Earth's size and shape. The shadow that falls on the moon is always curved. This curve reveals that Earth is round. Ancient astronomers observed this and used it as proof long before modern science confirmed it. Every time we watch a lunar eclipse, we see Earth's shadow stretching across space, touching the moon and leaving a record of Earth's shape on the lunar surface. It is a powerful symbol of how connected everything is. Another remarkable thing about lunar eclipses is their visibility. Anyone on the night side of Earth can see the eclipse. It does not matter where you are, whether in a city, a small town, or on a mountain. As long as the sky is clear, you can watch it. Solar eclipses, by comparison, require being in the right location. Lunar eclipses are shared globally by millions of people at once. They create a collective moment across countries, cultures, and languages. While the moon is in total eclipse, something else interesting happens. If you look closely, you might notice that different parts of the moon have slightly different shades of red or orange. This is because Earth's atmosphere bends light unevenly. Some areas of Earth have thicker clouds or more pollution, and the light traveling through those areas gets filtered differently. The result is a moon with a complex blend of colors. It is like a giant watercolor painting created by Earth itself. Totality in a lunar eclipse can last for a long time compared to solar eclipses. Some total lunar eclipses last more than an hour. This gives people plenty of time to relax under the night sky and enjoy the show. Photographers can take many pictures. Families can sit together and talk while watching the moon change. Some people even meditate during the event because of its calm and quiet atmosphere. The moon feels soft and gentle, like a glowing lantern hanging above us. Eventually, the eclipse begins to move in reverse. The moon starts leaving Earth's umbra. Light returns slowly, touching the edges first. The shadow moves away, and the full moon brightens again. The warm red fades, giving way to silver light. The moon looks normal once more, as if nothing unusual happened. But the memory stays in the minds of those who watched it. A lunar eclipse may be gentle, but its beauty stays with you long after the event ends. Throughout history, people have created stories to explain lunar eclipses. Many cultures believed that creatures or spirits were eating the moon. Others thought it was a sign of change, warning, or transition. In some ancient traditions, people would make noise, shout, or beat drums to scare away whatever they believed was attacking the moon. These stories show how deeply people felt connected to the sky. Even without understanding the science, they sensed that something important was happening. Later, scholars began to observe and record the movements of the moon. They noticed patterns and realized that eclipses were predictable. They learned that the moon's orbit, Earth's tilt, and the sun's position created cycles. One of the earliest known cycles is the Saros cycle, which lasts about 18 years. After this period, the geometry of the sun, Earth, and moon repeats, and a similar eclipse happens. This discovery allowed early astronomers to predict eclipses with surprising accuracy, giving them respect and authority in their communities. Today, scientists use advanced tools to track and predict eclipses. With modern models, we can forecast eclipses thousands of years into the future. We know exactly when and where they will occur. We understand why they happen, how long they will last, and what they will look like. But even with all this knowledge, the magic of an eclipse has not faded. People still gather in open fields, rooftops, parks, and hillsides to watch the moon turn red. They still feel a quiet excitement. They still look up with wonder. Lunar eclipses also help scientists study Earth's atmosphere. By analyzing the color and brightness of the moon during an eclipse, researchers can learn about the amount of dust and particles in Earth's sky. This helps them understand climate patterns and atmospheric changes. So lunar eclipses are not just beautiful, they are useful tools for understanding our planet. Both solar and lunar eclipses reveal how precisely the universe works. The Sun, Earth, and Moon move in predictable paths, held by gravity in a complex but orderly system. Most of the time, these motions go unnoticed, but during eclipses, the system becomes visible. It shows itself to us in light and shadow. It reminds us that we are part of a larger cosmic story. Eclipses also remind us of balance. Light and shadow are opposites, yet they depend on each other to create these events. Without shadow, there would be no eclipse. Without light, there would be nothing to block. The dance between the three bodies creates moments that are brief but powerful. A lunar eclipse does not change day into night, but it changes the moon into something new, something that glows with Earth's own filtered light. As the moon leaves the shadow and returns to its bright, familiar form, the night feels complete again. The sky settles back into its usual rhythm. But the eclipse leaves behind a memory of something rare and beautiful. It shows us that even the most constant things, like the moon, can surprise us. It reminds us that the universe is full of quiet wonders. The story of eclipses is, at its heart, a story of alignment. Things far apart in space come together in just the right way. Shadows travel across worlds. Light bends through air. The moon becomes red. The sun becomes a ring of fire. It is a reminder that even in the vastness of space, everything is connected. Eclipses give us a chance to witness that connection with our own eyes. To understand why eclipses are rare, imagine the sun, earth, and moon as three dancers moving in circles. Their motions are steady and predictable, but they do not move on the same flat floor. Each dancer is on a slightly tilted platform. Because of this tilt, they do not always line up in a straight line. Only when all three platforms tilt in just the right way, at just the right moment, does an eclipse take place. These perfect alignments are called syzygies, a word that sounds complex but simply means that celestial bodies line up. The moon's orbit around Earth is tilted by about 5 degrees compared to Earth's orbit around the sun. 5 degrees may sound small, but in space, even small angles make big differences. If the moon's orbit were not tilted, we would see a solar eclipse every month during the new moon and a lunar eclipse every month during the full moon. But because of the tilt, the moon usually passes above or below the sun when it is new, and above or below Earth's shadow when it is full. This is why eclipses happen only a few times a year. There are 2 points in the moon's orbit where it crosses the path of Earth around the sun. These crossing points are called the lunar nodes. When the moon is at one of these nodes and the sun is lined up with that same point, an eclipse becomes possible. But the moon must also be in the right phase. For a solar eclipse, the moon must be new. For a lunar eclipse, the moon must be full. Only when both the phase and the node line up do we get an eclipse. This combination is rare because the moon's phases and its position around Earth do not match perfectly every month. These matching moments happen during what scientists call eclipse seasons. An eclipse season lasts about 34 days, and during this time, at least one eclipse will occur, sometimes two. There can be a solar eclipse, a lunar eclipse, or both within the same season. After the season ends, Earth and the moon drift out of alignment again, and no eclipses happen until the next season arrives, about 6 months later. The regularity of these seasons shows how precise and steady the motions of celestial bodies are. Because the moon moves in an elliptical orbit, its distance from Earth changes. Sometimes it is closer, at a point called perigee. Sometimes it is farther away, at apogee. The difference in distance affects the size of the moon in the sky. When the moon is closer, it appears slightly larger. When it is farther, it looks a bit smaller. This is why some solar eclipses achieve totality, while others become annular. If the moon is too far away, it cannot fully cover the sun, even during perfect alignment. The sun also has an apparent size that changes slightly, depending on Earth's distance from it. Earth's orbit is not a perfect circle. It is slightly elliptical, which means Earth is closer to the sun at some times of the year and farther at others. When Earth is closer to the sun appears a little larger, making it harder for the moon to cover it completely. When Earth is farther, the sun looks a little smaller, making total eclipses more likely if alignment is good. These subtle variations reveal how delicate and sensitive eclipse conditions are. Even though the conditions for eclipses are strict, humans have always been skilled at noticing patterns. Ancient civilizations carefully watched the sky and kept records for generations. They discovered cycles long before telescopes existed. The Saros cycle, lasting about 18 years, is one of the most famous. After one Saros cycle, the Sun, Earth, and Moon return to nearly the same arrangement, and a very similar eclipse happens. This repeating cycle was used by Babylonian and Greek astronomers for predicting eclipses with impressive accuracy. Their work laid the foundation for modern astronomy. The Saros cycle works because of how three different motions line up: the Moon's orbit around Earth, the phases of the Moon, and the shifting position of the lunar nodes. When these three motions repeat in harmony, the geometry of the next eclipse becomes almost identical. The eclipse will occur at a similar distance between the Moon and Earth, making its appearance close to the previous one. But the location on Earth where it is visible shifts because Earth rotates and the timing of the alignment changes gradually. So even though the pattern repeats, the shadow falls on different regions of the world. While the Saros cycle is helpful, modern scientists use far more advanced tools. With computers, mathematical models, and data from satellites, scientists can predict the exact path, timing, and type of eclipse thousands of years into the future. These predictions include details such as how long totality will last and where on Earth the shadow will fall. This level of precision reflects the accuracy of our understanding of celestial motion. One fascinating detail about the Moon is that it is slowly moving away from Earth. Every year, it drifts about 4 centimeters farther into space. This is caused by the gravitational interaction between Earth and the Moon. Over millions of years, this small drift adds up. Long ago, the Moon was closer to Earth and appeared larger in the sky. Total solar eclipses were more common and lasted longer. Millions of years in the future, the Moon will be farther away and appear smaller. Eventually, it will no longer be able to cover the Sun completely. Future generations living far in the future will see only annular eclipses, never total ones. This means we are living in a special window of time where perfect total eclipses exist. Thinking about this change makes every eclipse feel even more precious. We are witnessing a cosmic alignment that is temporary in the long timeline of the universe. The Moon is drifting away so slowly that we do not notice it in our lifetimes. But the universe changes quietly, always moving and reshaping itself. Because of the Moon's drift and the shifting of Earth's rotation, each eclipse is slightly different. The path changes, the duration changes, the pattern of Bailey's beads changes, and even the shape of the corona changes. These differences create variety in what people experience. No two eclipses are exactly the same, even when the conditions appear similar. People who chase eclipses often describe the planning process as an adventure. They study eclipse maps, weather patterns, and the geography of the path. They choose where to stand to maximize their chances of seeing totality. Some travel across oceans or camp in remote areas just to stand inside the shadow for a few minutes. Their passion shows how deeply an eclipse can touch the human heart. They say the moment of totality is worth every effort. While solar eclipses involve the Moon's shadow touching Earth, lunar eclipses do the opposite. They show Earth's shadow touching the Moon. This highlights a simple but important truth. Earth also casts a shadow in space. At night, when Earth blocks sunlight from reaching the moon, the shadow becomes visible. It reminds us that Earth is a solid body moving through space, surrounded by darkness and light. When we see Earth's shadow on the moon, we see our own presence in the solar system. Another striking difference between solar and lunar eclipses is how they affect human behavior. Solar eclipses often create excitement, fear, or amazement because they change the day. Darkness in the middle of the day feels strange and dramatic. Lunar eclipses, in contrast, create a sense of calm. Watching a blood moon is more like observing a beautiful painting than witnessing a dramatic event. Both types of eclipses bring people together, but they do so in different emotional ways. In ancient times, people saw eclipses as signs or omens. Without understanding the science, they connected cosmic events to everyday life. A sudden darkening of the sun was frightening and often believed to signal danger. A red moon was seen as a message from the heavens. These beliefs shaped rituals, myths, and traditions. Some cultures believed that eclipses meant the gods were angry. Others saw them as battles between mythical creatures. These stories show how deeply people connected the sky with their emotions and their understanding of the world. But as knowledge grew, these fears changed into curiosity. People began to ask questions. Why does the shadow look curved? Why does the moon turn red? Why does the sun disappear only in certain places? These questions pushed human understanding forward. Eclipses became tools for learning, not warnings of disaster. When telescopes were invented, eclipses revealed even more. Scientists used them to map the moon's surface, measure the sun's size, study Earth's atmosphere, and test theories. The 1919 eclipse that confirmed general relativity was one of the greatest scientific achievements of the 20th century. This single event changed how we understand gravity, space, and time. Even today, scientists still learn from eclipses. They study how Earth's atmosphere bends and filters light during a lunar eclipse. They study the corona during a solar eclipse. They measure how fast Earth rotates by observing tiny timing differences in eclipses. Every eclipse adds one more piece to the story of our solar system. At the same time, eclipses continue to inspire people outside of science. Artists paint them, writers describe them in stories, travelers chase them, children watch them with wide eyes. They are events that connect logic with emotion, science with experience. The precision of eclipses shows how the universe follows patterns. Gravity guides the motions of celestial bodies with incredible accuracy. The mathematics that describes these motions allow us to predict eclipses far into the past and future. This predictability gives a sense of order to the universe. It shows that despite the vastness and complexity of space, some things follow clear rules. But eclipses also show the beauty within those rules. They turn ordinary skies into extraordinary scenes. They reveal what is usually hidden. They bring light and shadow into perfect harmony. They make us pause, look up, and remember that we are part of something far larger than ourselves. As the celestial dance continues, more eclipses will come. Some will be dramatic, with long paths of totality. Some will be gentle, with warm red moons. Some will be visible only from certain parts of the world. Others will be shared by millions. Each one will be part of a long story told by the sun, earth, and moon. A story that we have been watching since the beginning of human history. Eclipses have shaped human history in many surprising ways. Long before science explained them, eclipses were moments of mystery that left people shocked, frightened, or filled with awe. They interrupted the rhythm of daily life. They made the familiar sun or moon behave in unfamiliar ways. And because these events were so rare and dramatic, ancient civilizations often connected them to powerful stories, beliefs, and decisions. To understand how deeply eclipses touched early human life, imagine seeing one without any scientific explanation. Imagine watching the sun darken or the moon turn red in a world where people had no idea why such things happened. It would feel like a message from the heavens. In ancient China, people believed that solar eclipses were caused by a celestial dragon trying to swallow the sun. When the sun began to fade, people would rush outside, beating drums and making loud noises to scare the dragon away. This tradition continued for centuries. Even though the explanation was mythical, the reaction was meaningful. It showed how much people depended on the sun and how frightening it was to see its light disappear unexpectedly. In India, stories described a being named Rahu who tried to drink the nectar of immortality but was caught by the gods. His head was cut off, but because he had tasted the nectar, he remained alive. His head, Rahu, and his body, Ketu, wandered the sky. It was believed that Rahu occasionally swallowed the sun or the moon to take revenge, creating eclipses. But because he had no body, the sun or moon would reappear shortly afterward. These stories helped explain the sudden darkening in a way that felt poetic and powerful. In ancient Mesopotamia, eclipses were seen as warnings for the king. People believed that a lunar eclipse meant danger was coming, so the king would hide, and a substitute king would take his place for a short time. When the eclipse passed, the real king would return. This ritual shows how seriously these early civilizations took celestial events. They believed the sky held messages about their fate. The Maya civilization in Central America watched the sky with great precision. They had a deep understanding of astronomy and could predict eclipses with impressive accuracy. Their calendars and carvings reveal that they tracked the moon's motion closely. Although they mixed scientific observation with spiritual beliefs, their knowledge shows how carefully they studied the heavens. For them, eclipses were part of a larger cosmic cycle that guided their rituals and planning. In Viking mythology, two giant wolves chased the sun and the moon across the sky. When a wolf caught one of them, an eclipse occurred. People would shout and make noise to scare the wolves away. This story reflects how people across cultures reacted with sound and action when the sky changed. Even though the explanation was imaginative, it reflected a deep respect for the sun and moon. Stories like these form the emotional understanding of eclipses for thousands of years. People felt the events were signs, warnings, or battles between powerful cosmic beings. They did not know what caused them, but they knew they were unusual and meaningful. These stories were also ways for societies to stay connected through shared beliefs. But not every ancient reaction was based on fear. Many cultures saw eclipses as moments of wonder. In some traditions, they were symbols of renewal or transformation. In others, they were treated as sacred signs, reminding people of the order and structure of the universe. These interpretations show that eclipses were not only frightening, but also inspiring. They made people think about the sky, their lives, and the passage of time. As civilizations grew and science slowly developed, people began to search for patterns. They observed the moon's cycles, recorded the appearance of eclipses, and compared events across generations. This long-term observation revealed that eclipses follow regular cycles. The ancient Greeks, for example, learned about the Saros cycle, which repeats roughly every 18 years. After this time, a similar eclipse occurs again. This knowledge allowed them to predict eclipses with surprising accuracy. It was a major step forward in understanding celestial motion. One famous solar eclipse occurred in 585 BCE during a battle between the Medes and the Lydians. According to reports, the sky suddenly darkened and both armies stopped fighting immediately. They interpreted the eclipse as a sign from the gods that the battle should end. Peace was declared and the war came to a halt. This is one of the earliest recorded moments where an eclipse changed the course of human events. Another dramatic use of an eclipse happened with Christopher Columbus. During his fourth voyage to the Americas, Columbus found himself in a difficult situation. His crew was short on food, and the local people were no longer willing to help them. Columbus knew from astronomical tables that a lunar eclipse was coming. He told the local people that his god was angry and would make the moon disappear. When the eclipse began and the moon turned red, the people were frightened and agreed to help him again. Though this story shows manipulation, it also shows how powerful celestial knowledge can be when most people do not understand the sky. Eclipses also helped answer scientific questions long before modern instruments existed. When scientists observed lunar eclipses, they noticed that Earth's shadow on the moon was round. This helped prove that Earth itself must be round. This was an important discovery at a time when many people did not know the true shape of our planet. The curved shadow offered simple but strong evidence that Earth is not flat. This discovery laid the foundation for future explorations and scientific progress. Another major scientific breakthrough came during the total solar eclipse of 1919. Albert Einstein had predicted that gravity bends light. According to his new theory of general relativity, light traveling near the sun would curve because the sun's mass bends the space around it. But to test this idea, scientists needed to see stars near the sun's edge. Normally, the sun's brightness makes nearby stars invisible, but during a total eclipse, the sun becomes dark, and stars near its edge can be photographed. British astronomers travelled to two locations, one in Africa and one in Brazil, to take pictures during the eclipse. Their photos showed that the stars' positions shifted just as Einstein predicted. This moment proved a major part of modern physics and changed our understanding of the universe. And it was possible only because of a solar eclipse. Eclipses have also inspired artistic creations. Paintings, poems, sculptures, and songs across cultures have captured the strange beauty of a darkened sun or a red moon. Writers use eclipses to symbolize change, mystery, or revelation. Artists portray them as moments of power and transformation. Even in modern times, movies and stories often use eclipses as dramatic turning points. The emotional force of an eclipse continues to speak to the human imagination. Today, eclipses bring people together in a very different way from the past. Instead of fear, there is excitement. Instead of confusion, there is knowledge. People gather in large groups to watch total solar eclipses. They set up telescopes, cameras, and solar filters. They travel to mountains, deserts, cities, and coastlines. The event becomes a celebration of science and nature. Families, friends, strangers, and scientists stand together, looking up at the same sky. For a few minutes, everyone shares the same experience. Lunar eclipses create a quieter but equally meaningful moment. People sit under the night sky and watch the moon slowly turn red. They take pictures and talk softly. They enjoy the calmness of the event. It becomes a peaceful gathering, like watching a beautiful sunset or a rare meteor shower. These shared experiences connect people across the world. Millions of people may be watching the same moon from different countries, feeling a sense of connection through the sky. Eclipses also help us understand how cultures grow. In the past, eclipses created fear. Today, they create curiosity and excitement. This change shows how human knowledge evolves. We move from myth to observation, from observation to explanation, and from explanation to exploration. Eclipses helped push society along this path. They encouraged humans to study the sky, ask questions, and search for answers. They inspired scientific progress, technological development, and deeper understanding of the universe. Even though we now understand eclipses, they continue to create deep emotional reactions. When the sun disappears or the moon turns red, something inside us wakes up. It is a feeling that science can explain, but not replace. It is a reminder that the universe is enormous, ancient, and full of wonder. It is also a reminder that we are part of it. Standing under an eclipse makes you feel both small and connected. The sky becomes something you can feel, not just something you can see. Eclipses are moments when nature reveals its precise geometry. They show us the perfect timing of celestial motion. They show how three bodies in space can align so beautifully. They show the balance of light and shadow, distance and size. They show how the universe works not with chaos but with quiet order. And still, eclipses feel magical. They break the routine of daily life. They interrupt the normal flow of time. They show us a side of the sun and moon that we do not see on ordinary days. They remind us that the cosmos is full of hidden wonders, waiting for the right moment to appear. The deeper you explore eclipses, the more you realize how much they have shaped human understanding. They have influenced myths, history, science, art and culture. They have guided explorers, inspired scientists, and amazed ordinary people. Even today, they continue to bring millions of people together in shared wonder. And the story of eclipses is not only about the past, it is still unfolding. Future eclipses will create new discoveries, new stories, new memories. The sun, earth, and moon will continue their dance. The shadows will keep moving across worlds, and every time they align, the universe will again reveal something extraordinary. To understand how deeply eclipses help science, imagine them not just as beautiful events in the sky, but as powerful natural tools. They allow us to see things we normally cannot see. They let us measure things we normally cannot measure. They give scientists a chance to study the sun, the moon, and even Earth in ways that are impossible at any other time. Eclipses reveal hidden layers of the universe, and each event becomes a temporary laboratory in the sky. One of the most important scientific gifts of a total solar eclipse is the chance to study the solar corona. The corona is the outer layer of the sun's atmosphere. It glows with a soft white light that spreads far into space, but on normal days we cannot see it because the sun's bright surface overwhelms it. It is like trying to see the glow of a candle next to a huge spotlight. But during a total eclipse, the moon blocks the bright surface of the sun, allowing the faint corona to become visible. This creates a rare opportunity to observe its shape, brightness, and structure. The corona is incredibly hot. Surprisingly, it is much hotter than the surface of the sun, even though it is farther away from the sun's core. The surface of the sun is around 5,500 degrees Celsius, but the corona can reach over 1,000,000 degrees. This strange difference has puzzled scientists for many years. Eclipses allow researchers to study the corona's patterns, helping them understand how magnetic fields and energetic particles move around the sun. These studies also help predict solar storms, which can affect satellites, power grids, and communication systems on Earth. Eclipses have also helped scientists measure the shape of the moon's surface. When the moon passes in front of the sunlight shines through the small valleys and craters on the moon's edge, creating the effect known as Bailey's beads. By studying these beads, scientists can map the moon's edge with incredible accuracy. Before space missions existed, eclipses were one of the best ways to understand the moon's topography. Even today, the data from eclipses help refine our measurements of the moon's orbit and shape. Another major scientific discovery connected to eclipses happened in 1919 when Einstein's theory of general relativity was tested. According to Einstein, gravity can bend space and cause light to curve. This idea was revolutionary at the time. To test it, scientists needed to see stars that appear near the sun during an eclipse. Normally the sun's brightness blocks these stars from view, but during a total solar eclipse, the sun becomes dark, revealing the stars around it. By measuring how these star positions shifted because of the sun's gravity, scientists confirmed Einstein's prediction. The results matched his theory perfectly, and this eclipse became one of the most important scientific events of the 20th century. Eclipses also help scientists learn about Earth. During a total solar eclipse, Earth's temperature can drop noticeably. The sudden cooling affects the atmosphere, wind patterns, and even the behavior of animals. Scientists use instruments during eclipses to study these changes. They measure how fast the air cools, how clouds form, and how wind directions shift. These details help improve climate models and teach us more about how Earth responds to sudden changes in sunlight. During lunar eclipses, Earth's atmosphere also becomes easier to study. As Earth's shadow falls on the Moon, sunlight passes through our atmosphere before reaching the Moon's surface. Scientists analyze this filtered light to understand what particles, dust or gases are present in Earth's air. In simple terms, the Moon becomes a giant reflector, showing what our atmosphere looks like from space. This method helps scientists detect volcanic ash, pollution, and other atmospheric features. So while we watch a blood moon for its beauty, researchers are using it to study the health of Earth's atmosphere. Lunar eclipses also help scientists understand the Moon's composition. The way the Moon's surface reflects red light reveals information about different minerals in its soil. When scientists compare the brightness and color of different regions during an eclipse, they can learn more about the Moon's geology. This adds to the data collected from lunar missions and telescopes. It shows how even simple observations during an eclipse hold scientific value. Beyond the Sun, Moon and Earth, eclipses also help us learn about other planets. Astronomers use similar ideas to study exoplanets, which are planets orbiting stars far outside our solar system. When an exoplanet passes in front of its star, it creates a tiny eclipse. The star's brightness dips slightly. By measuring this tiny dip, scientists learn about the size of the planet, its orbit, and sometimes even the chemicals in its atmosphere. This technique has helped discover thousands of planets around distant stars. In a way, studying eclipses in our own sky helped humanity learn how to find worlds far beyond it. Eclipses played a major role in improving our understanding of orbital mechanics. Scientists use precise observations of eclipses to refine the values of Earth's rotation, the Moon's distance, and even the subtle wobble in Earth's axis. These measurements help make our calendars, navigation systems, and timekeeping more accurate. Even slight changes in Earth's rotation can be detected by comparing modern eclipse times with records from hundreds or thousands of years ago. Eclipses act like markers in time, helping scientists understand how Earth has changed. Another powerful scientific use of eclipses is in calibrating satellites. When the Moon or Earth blocks the Sun, satellites experience changes in temperature and light conditions that help engineers test how the instruments respond. These observations help improve the design of satellites used for studying weather, climate, or distant galaxies. So even when we do not look at eclipses directly, they still influence our technology. Eclipses also reveal interesting details about the Sun's atmosphere beyond the corona. For example, the chromosphere, a reddish layer just above the Sun's surface, becomes visible for a few seconds during totality. This thin layer is usually hidden by the Sun's brightness, but during an eclipse it appears like a thin pink ring around the Moon. Studying this layer helps scientists understand how energy moves from the Sun's surface into its outer layers. Even the shape of the corona changes depending on the Sun's activity. During quiet periods in the solar cycle, the corona is more symmetrical and spreads outward in simple patterns. During active periods, the corona becomes more chaotic, shaped by strong magnetic forces. By comparing coronas from different eclipses over the years, scientists track how the Sun's activity changes over time. This is important because solar activity affects space weather, which can disrupt satellites, GPS signals, and power systems on Earth. But eclipses are not only used for science, they also create emotional experiences that science cannot measure. Everyone who has stood under a total solar eclipse says the same thing. Photographs and videos do not capture the real feeling. The moment the Sun disappears, something shifts inside you. You feel the world pause. You feel like you're witnessing something older than human history. This emotional impact influences how people connect to science. Sometimes a single eclipse experience inspires someone to study astronomy, physics, or space exploration. Because eclipses can be predicted so precisely, researchers often plan huge scientific campaigns around them. Teams set up telescopes, cameras, spectrometers, weather instruments, and sensors. They travel to remote places where the sky is clear, preparing for months or even years for just a few minutes of totality. This dedication shows how valuable eclipses are for scientific progress. The data collected during those short minutes can lead to discoveries that reshape our understanding of the Sun and Earth. Scientists also use eclipses to study how the human body reacts to rapid environmental changes. The sudden drop in light and temperature affects hormones, stress levels, and circadian rhythms. Observing these reactions helps researchers understand how humans adapt to changing environments. Animals also respond in surprising ways. Birds stop singing, insects change their patterns, and some animals behave as if night has come early. These responses offer insights into animal behavior and biological clocks. Even beyond Earth's atmosphere, eclipses help us understand how light behaves in space. When light bends, scatters, or reflects, it reveals information about the objects it touches. The bending of starlight during eclipses helped confirm relativity. The scattering of sunlight during lunar eclipses helps understand atmospheric particles. The blocking of starlight by distant planets helps find new worlds. Every eclipse, big or small, becomes a tool for discovery. At the same time, eclipses remind us of something simple but profound. We are part of a moving universe. The Sun is not simply a bright object. It is a massive star with layers, storms, and energy fields. The Moon is not just a glowing circle. It is a rocky world with mountains, craters, and a history of billions of years. Earth is not a fixed stage, but a rotating and orbiting planet, casting its own shadow across space. Eclipses bring all of this together in one moment, showing how these three worlds interact. Understanding eclipses deepens our appreciation of celestial motion. It encourages us to see the sky not as a static backdrop, but as a living system. It helps us understand that light and shadow are not opposites, but partners shaping the way we experience the universe. It shows us that even simple events, like a shadow falling on a surface, can reveal complex truths about gravity, motion, and time. The science of eclipses continues to grow. Modern instruments capture details we never noticed before. Space telescopes observe eclipses from above Earth's atmosphere. Artificial intelligence helps analyze patterns in eclipse images. New discoveries arrive every decade. But even as our scientific understanding expands, the emotional wonder of eclipses remains the same. They still make people stop, look up, and think about their place in the universe. Science explains how eclipses happen. But the experience of an eclipse explains why people care. It brings together knowledge and feeling, logic and awe. It reminds us that we live in a universe full of extraordinary moments that appear without warning, last only briefly, and then fade into memory. As we continue exploring this story, we see that eclipses have shaped not only science, but also culture, imagination, and human behavior. They influence how we think about time, nature, and the cosmos. They remind us that the universe is constantly moving, and sometimes these motions line up in ways that reveal something incredible. When people think about experiencing an eclipse, they often imagine the moment itself, but the journey leading to that moment can be just as meaningful. A total solar eclipse is not something you can casually watch from anywhere. You need to be in the right place at the right time. The shadow of the moon touches Earth in a narrow path, and only the people standing inside that path get to experience totality. Because of this, watching a solar eclipse becomes a kind of adventure. It requires planning, movement, and sometimes even courage. People travel across the world for just a few minutes of darkness, and the journey becomes part of the story. Imagine setting out before sunrise, driving across quiet roads toward a place where the shadow will pass. You might join thousands of people gathered along a coastline, in an open field, or on the top of a mountain. Some bring telescopes and cameras, others just bring blankets and snacks. Families, students, travelers, and scientists all come together, waiting for the moment the sun will hide. There is a sense of community. Strangers talk to one another, sharing excitement and stories. Children run around, not fully understanding what is about to happen but sensing that something special is coming. Adults check the time and glance toward the sky again and again. As the moon begins to cover the sun, the light changes slowly. It becomes softer, cooler, and stranger. The shadows under trees start to show tiny crescent shapes because the sunlight is being filtered by the shape of the sun behind the moon. People notice these details and point them out to one another. A gentle feeling spreads across the group. It is like everyone is preparing for a shared experience that goes beyond words. Then, as totality approaches, everything changes quickly. The light drops in a way that feels unnatural. The world becomes quiet. The temperature falls. The sky looks like evening, but the sun is still high. People gasp, whisper, or simply stare. When the last beam of sunlight appears as a sparkling diamond ring, a wave of emotion passes through the crowd. And when the sun disappears completely, the moment is unforgettable. The corona shines like a soft halo around the moon. Stars become visible. The landscape looks like twilight frozen in place. For a few minutes, people feel a deep connection, not only to the sky but also to each other. Everyone is experiencing the same rare moment. When totality ends and the sunlight returns, people often cheer. They smile at strangers, laugh, or even cry. The journey is worth it, no matter how far they traveled. Preparing to watch a solar eclipse also requires understanding how to stay safe. Looking directly at the sun is extremely dangerous. Even when the moon covers most of it, the remaining sunlight can damage the eyes. That is why special eclipse glasses are needed. These glasses contain filters that block harmful rays while allowing you to see the sun safely. Without them, the sun's brightness can burn the retina, causing permanent vision loss. Regular sunglasses or dark films do not work. Proper certified eclipse glasses or solar filters must be used. Some people also use pinhole projectors or telescopes with safe filters. A pinhole projector is simple. It allows sunlight to pass through a small hole and project an image of the sun onto a surface. This lets you watch the eclipse without looking at the sun directly. Telescopes, cameras, and binoculars must always have special filters attached to the front. Without these filters, they can concentrate sunlight and cause severe injury. Safety is a major part of eclipse watching, and understanding it makes the experience more comfortable and enjoyable. During totality, however, the rules change briefly. When the sun is completely covered, it becomes safe to look at the sky without filters. This is the only time you can remove eclipse glasses. The corona is not bright enough to harm your eyes, but the moment totality ends and the sun begins to peek out again, the glasses must be worn once more. People sometimes forget this in the excitement, so reminders are important. Traveling to watch an eclipse also teaches people patience and respect for nature. Weather plays a major role. Even if you stand in the perfect place, clouds can block the view. This unpredictability adds excitement, but also anxiety. People track weather forecasts for weeks or months before an eclipse. They choose locations with a history of clear skies. Some even change their plans at the last minute if weather threatens their chances. This creates a feeling of suspense. Will the clouds part in time? Will the sky open up for the shadow to reveal its beauty? When the weather cooperates, the experience becomes unforgettable. But even when clouds appear, something magical can still happen. The sky still darkens, the temperature still drops, and the atmosphere still changes. Even if the corona is hidden, the feeling of totality remains. People often cheer afterward, grateful just to have felt the moment, even if the view was imperfect. Lunar eclipses create a different kind of journey. They do not require travel to a narrow path. They can be seen from anywhere on the night side of Earth. This makes them more relaxed and accessible. People gather in parks, rooftops, balconies, or quiet fields. They bring chairs, hot drinks, and sometimes music. The moon takes its time entering Earth's shadow, allowing everyone to settle into the moment. There is no rush, no pressure. The moon changes, slowly, inviting reflection and calm. Watching a lunar eclipse can feel like watching a long, beautiful performance. As the shadow grows, the moon becomes dimmer. When the red color appears, people often react with quiet amazement. The transformation is gentle and steady. It creates an atmosphere of peace. People talk softly, take photos, or simply look up in silence. Lunar eclipses become opportunities for families to spend meaningful time together, for friends to reconnect, or for individuals to enjoy a moment of stillness. Both types of eclipses create shared memories. Years later, people still remember where they were when the sun turned dark or the moon turned red. They remember who was with them, what they felt, and what the sky looked like. These memories stay vivid because eclipses are rare. They happen on a scale that reminds people of the universe's complexity, yet they unfold in a way that feels personal. These experiences also show how eclipses bring people together across cultures. In many countries, eclipse festivals take place. Scientists give talks, schools organize viewing events, and communities gather to celebrate. Local traditions blend with modern science, creating a unique atmosphere. Some places hold music performances, art exhibitions, or storytelling sessions connected to the eclipse. It becomes a cultural moment as well as a scientific one. Eclipses also inspire travel and exploration. Many people use them as an excuse to visit new places. They might travel to deserts, islands, mountain ranges, or remote villages. This turns the eclipse into both an adventure and a lesson in geography. Travelers meet new people, see new landscapes, and experience new cultures. The eclipse becomes the highlight of a journey filled with discovery. For many, the most profound experience comes from standing under the shadow of the moon. The feeling is difficult to describe. It is not just darkness. It is the sudden silence, the change in the wind, the shifting colors of the sky. It is the sense that the world is holding its breath. The moment feels ancient, as if time has paused. People often say it feels spiritual or emotional, even if they do not normally think in those terms. It touches something deep inside, something connected to wonder. Lunar eclipses create a different but equally deep feeling. They allow people to see Earth's influence in the sky. They show how Earth casts a shadow across space. They reveal how light bends through our atmosphere. Watching the moon turn red makes people think about Earth in a new way. It reminds us that we are part of a larger system, connected to both the sun and the moon. The human reaction to eclipses also tells us something about ourselves. It shows that even in a world full of screens and technology, people still crave real experiences. They still want to witness something natural and powerful. They still feel awe when the sky behaves in unexpected ways. Eclipses reconnect people with the natural world, reminding them that nature can still surprise and amaze. Eclipses strengthen community bonds. When people gather to watch, they share stories, emotions, and excitement. They forget their differences for a moment. They look up at the same sky, united by curiosity and wonder. This shared experience can feel rare in today's world, where distractions are everywhere. But during an eclipse, attention focuses on one beautiful event. The world slows down. Eclipses also spark imagination. Children who watch them may grow up wanting to become scientists, astronauts, or artists. Adults rediscover their sense of curiosity. Artists create new works. Writers craft stories. Musicians compose songs inspired by the moment. The event becomes a well of inspiration that people draw from long after the shadow fades. No matter how many eclipses happen, each one feels unique. The sky, the weather, the people, and the surroundings all create a different atmosphere. Some eclipses are peaceful. Others are loud and celebratory. Some are crowded with thousands of viewers. Others are quiet moments shared by only a few. Each eclipse becomes its own story, told by everyone who witnessed it. Eclipses remind us that beauty often comes from rare, fleeting moments. They teach us to appreciate the present, to look up, to pause. They show us how the movements of distant worlds affect our own. They reveal the delicate balance of nature. When sunlight, shadow, and motion align perfectly, the sky transforms. We witness something that feels impossible, yet completely real. The journey to an eclipse, the waiting, the shared excitement, the careful preparation, the sudden change in the sky. All these elements come together to create a powerful experience. It becomes more than just a moment. It becomes a memory, a story, a connection to the universe. And as long as the sun, earth, and moon continue their dance, more eclipses will come. More journeys will begin. More people will look up at the sky and feel the same wonder that humans have felt for thousands of years. The story of eclipses is not only about science or history, it is also about us, our curiosity, our courage, our love for beauty, and our desire to understand the universe. Every eclipse tells a story about the past, the present, and the future. The sky we see today is not the same sky that ancient humans saw thousands of years ago, and it will not be the same sky that people many generations from now will see. The sun, earth, and moon are constantly changing. Their distances shift, their motions adjust, and their relationships evolve. When you study eclipses, you are also studying the slow and quiet changes of the solar system. These changes happen over millions of years, yet eclipses allow us to notice their effects through careful observation and history. One of the most important long-term changes is the slow drift of the moon. Every year, the moon moves a tiny bit farther away from Earth, about 4 centimeters. This seems incredibly small, but over millions of years, it becomes a huge distance. Long ago, when Earth was young, the moon was much closer. The tides were stronger, the moon looked larger in the sky, and total solar eclipses lasted longer. Imagine a time when the moon covered the sun with more force, and the path of totality was wider. That ancient sky must have looked very different from the one we see today. As the moon drifts away, its apparent size in the sky becomes smaller. This means that millions of years in the future, the moon will no longer be able to cover the sun completely. Total solar eclipses will become impossible. Only annular eclipses, the ring of fire type, will exist. The idea that total eclipses are temporary in Earth's history makes our era feel special. We are living at a rare moment in the lifetime of the solar system. Humans have the privilege to witness perfect total eclipses, but this privilege will not last forever. This fact gives every eclipse a deeper sense of meaning. Earth is also changing slowly. Its rotation is gradually slowing down because of the gravitational pull of the moon. This slow change affects the length of the day. A day on Earth long ago was shorter than 24 hours. As the rotation slows, the timing of eclipses changes too. Scientists compare ancient eclipse records with modern predictions to understand how Earth's rotation has shifted. These comparisons help reveal how the planet has evolved over thousands of years. Eclipses act like tiny timestamps, marking the rhythm of Earth's motion. When scientists study old writings and carvings from ancient civilizations, they look for eclipse descriptions. Some cultures wrote about the sky darkening, the moon turning red, or strange shadows appearing. These records help modern scientists figure out where eclipses were visible in the past. If the timing of an ancient eclipse does not match present-day predictions, it suggests that Earth's rotation has changed slightly. In this way, eclipses help us understand not just the sky, but Earth itself. Looking into the future, scientists can predict eclipses thousands of years ahead. They know when each eclipse will happen, where the shadow will fall, how long totality will last, and whether the eclipse will be partial, annular, hybrid, or total. These predictions are created using detailed mathematical models of celestial motion. The accuracy of these models shows how well we understand the mechanics of the solar system. The future holds many remarkable eclipses. Some will cross over oceans, some over deserts, and some over crowded cities. People in different parts of the world will have their own unique experiences. Children born today may watch their first eclipse many years from now, perhaps even in a different country. They might grow up remembering the excitement just as adults today remember the first time they saw the sun become dark or the moon turn red. Scientists also study how eclipses can help explore other planets. When a moon of another planet passes in front of the sun, it creates an eclipse visible to spacecraft. For example, the moons of Jupiter and Saturn create eclipses that spacecraft have captured. These events help scientists study the atmospheres of gas giants, measure their storms, and learn about the size and motion of their moons. Eclipses are not just Earth-based events. They happen throughout the universe, each one revealing something about the worlds beyond our own. In distant solar systems, astronomers use eclipse-like events to detect exoplanets. When a planet passes in front of its star, it creates a small dip in the star's brightness. This dip is extremely tiny, but sensitive instruments can measure it. This method, called the transit method, has helped discover thousands of planets. Some are large and hot, others small and rocky. Some might even have atmospheres similar to Earth's. All of this is possible because the simple idea of a shadow passing across a light source works everywhere in the universe. The same principle that makes a solar eclipse visible on Earth allows us to detect planets dozens or hundreds of light years away. Eclipses also play a role in studying the atmospheres of those distant planets. When an exoplanet passes in front of its star, some of the starlight filters through the planet's atmosphere before reaching telescopes. This filtered light carries information about the gases in the atmosphere. By studying these light patterns, scientists can learn whether the planet has water vapor, methane, carbon dioxide, or other important molecules. In other words, eclipses help us search for worlds that might support life. They serve as the first step in understanding the chemistry of planets far beyond our reach. Back on Earth, eclipses continue to shape our understanding of the Sun. The Sun is a complex and active star. It produces solar winds, magnetic storms, and bursts of energetic particles. These events affect Earth's technology, satellites, and communication systems. Studying the Sun during eclipses helps scientists understand the forces involved. The shape of the corona reveals changes in the solar cycle. By comparing coronas from different eclipses over the decades, scientists see how the Sun evolves. Eclipses also offer a unique opportunity to study the lower atmosphere of the Sun, especially the chromosphere. This layer is visible for only a few seconds at the start and end of totality. Its reddish glow is delicate and fleeting, but it holds important clues about how energy moves from the Sun's surface into its outer layers. Understanding these processes helps improve forecasts of solar storms, which is important for protecting satellites, power grids, and even astronauts in space. In addition to scientific value, eclipses highlight humanity's ability to observe patterns and predict the future. Thousands of years ago, humans did not know why eclipses happened. They told stories to explain the sky. Over time, observation turned into knowledge. Knowledge turned into calculations. Calculations turned into predictions. Today, predictions stretch thousands of years in both directions, past and future. This growth mirrors the development of human thought. It shows how curiosity, patience, and observation can transform our understanding of the world. Eclipses also highlight collaboration. scientists across continents work together to study these events. They share data, images, and discoveries. Students, teachers, and families participate in observations. Space agencies coordinate with researchers to capture images from aircraft, balloons, and satellites. These combined efforts show how a single, natural event can unite global communities in learning and discovery. In modern times, eclipses inspire new technology. Special cameras, sensors, and telescopes are designed to capture eclipse details. High-altitude balloons carry instruments into the stratosphere during an eclipse. Airplanes chase the shadow of totality to extend their viewing time. Satellites watch the eclipse from space, capturing the shadow moving across Earth's surface. These technologies help scientists gather information that cannot be collected at any other time. Eclipses also inspire creativity beyond science. Filmmakers create dramatic scenes around them. Writers use eclipses as symbols of change, transformation, or revelation. Artists paint the corona, the blood moon, and the strange colors of the sky during totality. Musicians compose songs inspired by eclipse moments. The events become part of human culture, expanding into stories, memories, and traditions. But even with all the knowledge and technology available today, eclipses still carry a sense of mystery. Not mystery in the sense of confusion, but in the sense of emotional depth. People who watch totality say it feels different from anything else. It feels ancient, as if time has opened a doorway to the past. It feels cosmic, as if the universe is reminding us of its vastness. It feels personal, as if the sky is speaking directly to the observer. These feelings cannot be explained fully by science, yet they are as real as the shadow itself. When you think about eclipses in the future, you can imagine generations of people looking up at the same sun and moon. They will watch eclipses from new cities, new countries, maybe even new worlds if humanity travels beyond Earth. They will use more advanced technology, but their emotional reactions will likely remain the same. Awe does not age, wonder does not fade. The universe will continue presenting these moments as long as the sun, Earth, and moon remain in their beautiful, delicate dance. Eclipses remind us of time. They remind us that everything changes, distances shift, orbits move, shadows fall in new patterns. What we see today is one moment in a long cosmic story. Eclipses help us feel that story, not just understand it. They show us that we are part of a universe that is always moving, always changing, yet still capable of creating moments of perfect alignment. And as long as these alignments continue, humanity will keep looking up, waiting for the next time the sky transforms. They will wait for the moon to turn red or for the sun to become a dark circle with a shining crown. They will gather, watch, cheer, whisper, and dream. They will continue the ancient tradition of looking at the sky with both curiosity and wonder. As we come to the end of this long journey through the world of eclipses, it becomes clear that these events are far more than just shadows passing across the sky. They are moments where the universe reveals its structure in a dramatic, beautiful way. They remind us how light and darkness shape our world. They show us how three celestial bodies, moving through space with perfect timing, can create scenes that feel almost unreal. And they teach us something important about ourselves, our curiosity, and our place in the cosmos. Think about everything that happens during an eclipse. The sun, earth, and moon move continuously, following their paths with quiet precision. Most of the time, these motions go unnoticed. Days pass, nights fall, seasons change, the moon waxes and wanes, and life continues without interruption. But then, one day, these motions align so perfectly that something extraordinary occurs. The familiar circle of the sun becomes dark, or the bright moon becomes red. It is as if the universe pauses for a moment to show us a hidden chapter of its story. Eclipses remind us that the sky is alive. It is not a flat ceiling above our heads. It is a vast, dynamic space, filled with motion, gravity, and energy. Every eclipse is a sign that we live in a connected system. The sun provides light and heat. Earth offers the stage we stand on. The moon adds balance, tides, and beauty. These three bodies interact in ways that create not only daily life, but also rare and breathtaking spectacles. When we watch an eclipse, we feel this connection. We feel the movement of worlds. We feel the passing of time. We feel something ancient and universal. People thousands of years ago looked up at the same sun and moon. They felt wonder, fear, confusion, and joy. Today, we feel the same emotions, but with a deeper understanding of what is happening. Our knowledge has grown, but our sense of awe remains. One powerful idea that eclipses reveal is the fragility of perfect alignment. Everything has to be just right for an eclipse to occur. The moon has to be in the correct phase. The tilt of its orbit has to match Earth's position. The distances between the bodies have to fall within certain ranges. Even small changes in these conditions would erase the event entirely. This delicate balance shows how precise the universe can be. Light and shadow meet in exactly the right way to create a moment that feels both natural and miraculous. Eclipses also show us the passage of time on a grand scale. The moon is drifting away, Earth is slowing down. The sun changes its activity every 11 years. These slow changes shape the appearance and frequency of eclipses. They remind us that nothing in the universe stays the same forever. But even as things change, patterns remain. Eclipses have happened for billions of years, and they will continue for billions more, even if their appearance shifts. They are markers of cosmic time, signs of the universe's slow evolution. On a human scale, eclipses teach patience. They remind us that the most meaningful moments often take years of waiting. They come rarely, last briefly, and then become treasured memories. People travel long distances, study eclipse maps, watch forecasts, and prepare equipment, all for a few minutes of darkness or a few hours of quiet transformation. This effort shows how much people value wonder. It shows that even in a busy world, some moments are worth slowing down for. Watching a total solar eclipse is an experience that stays in the heart. The sudden darkness, the cool air, the strange shadows, the glowing corona, the shimmering light during the diamond ring effect, the way people gasp, cheer, or stand in silence, the feeling that everything has shifted, even if only for a moment. These sensations become part of a person's memory forever. No photo or video fully captures the experience, because the experience is not just visual, it is emotional, it is physical, it is something you feel deep inside. A lunar eclipse creates a different type of memory. It is slower and more calming. Watching the moon turn red invites reflection. The night feels peaceful, you see Earth's shadow touching the moon, and feel connected to something larger. You realize that Earth too is an object in space casting shadows. You understand that our world is not isolated, it interacts with everything around it. Lunar eclipses give people time to think, relax, and simply enjoy the beauty of the night sky. Eclipses also reveal how humans respond to rare events. In the past, people reacted with fear and myths. Today, people react with excitement and curiosity. This evolution reflects our journey as a species. We have moved from stories of dragons and gods to science and exploration. But even with all our knowledge, we still feel humbled when the sky changes. We still look up. We still wonder. Modern technology allows us to understand eclipses in incredible detail. We can predict when eclipses will happen thousands of years in advance. We can watch them from airplanes, satellites, and space stations. We can study the corona, measure light, test theories, and collect data. Yet technology does not take away the magic. If anything, it enhances our appreciation. Knowing the science behind an eclipse makes the experience even more meaningful. You see the beauty and you also understand the forces behind it. Eclipses bring people together, communities gather, families make plans, friends travel long distances, scientists share discoveries, photographers follow the shadow, teachers bring students outside to learn from the sky. For a short time, people put aside their worries and look up at the same event. In a world full of differences, eclipses create unity. They remind us that we all share the same planet, the same sun, and the same moon. They also remind us of perspective. When the sun disappears or the moon turns red, our everyday concerns feel small for a moment. We are reminded that life is part of something vast. The universe is not centered around us. We are simply inhabitants of a moving world within a greater system. This realization brings a sense of clarity. It helps us appreciate our lives in a new way. Eclipses also symbolize change. They show that darkness can come suddenly, but also pass. They show that light can return just as quickly. They show that endings and beginnings are part of the same cycle. Many cultures use eclipses as symbols for transformation, renewal, or reflection. Even today, some people treat an eclipse as a moment to pause, rethink, or reconnect with themselves. As we imagine the future, eclipses will continue to inspire new generations. Children will grow up watching lunar eclipses from their windows. Students will learn about the sun and moon through eclipse models. Travelers will follow the paths of totality across different continents. Scientists will study the corona with more advanced instruments. Perhaps humans will one day view eclipses from the moon or Mars, watching Earth cast its shadow in a way we have never seen before. The possibilities are endless, but even in the distant future, the emotional core of an eclipse will remain the same. People will still feel wonder. They will still gather outside with family and friends. They will still look up at the darkened sun or glowing moon and feel small in the best way. Eclipses will continue to connect hearts across time, reminding people of their shared curiosity and shared world. As we close this journey, think once more about the sun, earth, and moon, three worlds, each moving quietly in its orbit, each shaping the lives of billions of people without being noticed. Yet when they come into alignment, they create a moment that captures the attention of the entire planet. They show that even ordinary motions can create extraordinary beauty when everything aligns. Eclipses are gifts. They are reminders of cosmic precision and natural harmony. They are evidence that the universe is full of patterns, rhythms, and wonders. They teach us patience, curiosity, and humility. They show us how light and shadow shape our lives. They help us see our world not as a small and isolated place, but as a part of a grand and elegant system. And so the next time an eclipse approaches, take a moment to pause, step outside, look up, feel the air change, watch the light shift. Let the sky show you something rare. Let it remind you that the universe is always in motion, always aligning, always creating moments meant to be seen and remembered. Eclipses may be brief, but their impact lasts far longer. They stay in memories, inspire dreams, and spark questions. They remind us that beauty can appear suddenly, unfold quietly, and then fade away, leaving behind a sense of wonder. As long as the sun shines, the moon orbits, and Earth turns, eclipses will continue to visit our sky. And every time they do, they will whisper the same message. The universe is alive, it is moving, and you are part of it. As we come to the end of this journey, take a moment to remember what we just explored. A solar eclipse turning day into twilight. A lunar eclipse painting the moon in red. Ancient stories, scientific discoveries, and the quiet precision of the sun, earth, and moon moving in perfect balance. These rare moments in the sky remind us that we live in a universe full of motion, mystery, and wonder. They show us that even everyday objects like the sun and moon can surprise us when the timing is right. Eclipses pass quickly, but the feeling they leave behind lasts much longer. They inspire curiosity, bring people together, and make us look up with a sense of gratitude for the beauty above us. And every time an eclipse happens, it whispers the same message. The universe is alive, and we are part of its story. Thank you for spending this time with us. If you enjoyed this video and want to explore more fascinating wonders of space and science, please like the video, subscribe to the channel, and share it with someone who loves the sky. We'll see you in the next journey.